Good day everyone. By the way, I am Jinjin Maruwang. In this video, I will discuss one of the CPU scheduling algorithms in operating systems called first come first serve or FCFS. This presentation explains how FCFS works, its advantages, disadvantages, and when it is be used. First come, first serve is one of the simplest CPU scheduling algorithms. In FCFS, processes are executed in the exact order in which they arrive in the ready queue. It follows the concept of a line or queue, where the first process that arrives is the first one to be executed. FCFS is classified as non-preemptive scheduling algorithm. This means that once a process starts executing in the CPU, it continues running until it finishes. No other process can interrupt it, even if a shorter or more important process arrives. Let us now look at how FCFS works step by step. First, process arrive in the ready queue. Second, the CPU selects the process that arrived first. Third, the selected process runs continuously until completion. Finally, the next process in the queue is executed. This process continues until all processes are completed. Before going further, let us define some important terms. Arrival time is the time when a process enters the ready queue. Burst time is the total CPU time required by a process. Waiting time is the time a process waits before it starts executing. Turnaround time is the total time from arrival until the process finishes execution. Now, let us look at the sample process table. We have three processes, P1, P2, and P3. Process P1 arrives at time 0 and has a burst time of 5 units. Process P2 arrives at time 1 with a burst time of 3 units. Process P3 arrives at time 2 with a burst time of 4 units. These values will help us determine the execution order using the first come, first serve scheduling algorithm. Based on the arrival times, we can now determine the scheduling order. Process P1 is executed first because it arrived earliest at time 0. Process P2 is executed next since it arrived after P1. Finally, process P3 is executed last because it arrived at time 2. This order clearly follows the FCFS rule. First arrival, first execution. This table represents the Gantt chart, which shows how CPU time is allocated. At time 0, process P1 starts executing and runs until time 5. After P1 finishes, process P2 starts at time 5 and runs until time 8. Then process P3 starts at time 8 and complete at time 12. The Gantt chart clearly shows that each process runs continuously until completion, which confirms that FCFS is a non-preemptive algorithm. Next, we calculate the waiting time for each process. Process P1 starts immediately at time 0, so its waiting time is 0. Process P2 arrives at time 1, but starts executing at time 5, So it waits for 4 time units. Process P3 arrives at time 2 and starts at time 8, resulting in a waiting time of 6 time units. This shows that process arriving later can experience longer waiting in FCFS. We have formula here. Waiting time equals to start time minus arrival time. Average waiting time 0 plus 4 plus 6 plus 6. Divide 4 equal, then 6, 0 plus 4 plus 6 plus 6 equals 16. Divide 4 equals 4. Finally, we calculate the turnaround time for each process. Process P1 finishes at time 5, so its turnaround time is 5 units. Process P2 finishes at time 8, giving it a turnaround time of 7 units. Process P3 finishes at time 12, resulting in a turnaround time of 10 units. Turnaround time includes both the waiting time and the burst time of the process. The formula of turnaround time equal to completion time minus arrival time. Average turnaround time equals 5 plus 7 plus 10 equals 22 because we divide 4. Then 22 divide 4 equals 5.5. FCFS has several advantages. It is very simple and easy to implement. It is fair in terms of arrival orders. Also, it does not cause starvation because every process will eventually be executed. However, FCFS also has disadvantages. It can cause long waiting times, especially for short processes. It suffers from the convoy effect, where short processes wait behind long ones. As a result, it has poor performance in systems with mixed job sizes. FCFS is best used in simple batch systems. It is also useful when job order is important. Additionally, it works better in systems where process burst time do not vary greatly. To summarize, FCFS is the simplest CPU scheduling algorithm. It executes processes in the order they arrive. While it is easy to understand and implement, it is less efficient compared to another algorithm like shortest job first and round robin. Thank you for watching po.